Okay, quick show of hands. Who's building agents here? Just so I get a sense of. Okay, so hopefully at the end of this talk, I'll try to impart all of the lessons, at least all the most important lessons I've learned building our agent, and you can hopefully improve your agent based on this talk. So that's the promise. So our focus at Cleric is to build an agent that we call like a self-learning AI agent, and I think that's the future, like the next step of the evolution of building a really compelling agent. So maybe just a quick intro about us. It's an SRE agent, site reliability engineering, and our whole mission is to free engineers from having to be on call. The reason I want to show this is that a lot of the examples I'm going to show you are very SRE or on-call focused, but I've tried my best to make sure it's generalizable enough that you can apply the patterns with our agent to whatever it is that you guys are building, right? So let's start with an example of like an agent screwing up. So this is an example from like a very simplified version of something that we go through quite a lot. So just to give as an on-call agent, if you are on call, you probably experience the same thing. An alert comes in, you have to drop what you're doing, you got to jump on, do some investigation, figure out what went wrong, and then try to fix it, right? So in this case, let's say that there's an alert that pops up that there's some consumer lag that spiked to 4,000, right, over the last 2 minutes. So now the agent, so Cleric, jumps on, is like, okay, that looks bad, I'm going to go check it out. So it starts observing that, okay, there's a consumer lag, there's a failure, and so it does a good job to know that this is actually a problem. Then it's like, all right, it's a Kafka failure. It's on Kubernetes, so I've got to go and check, out of 20 different systems, I'm going to figure out what are the right systems for me to look at, and then pull as much information from it, right? So it gets that right as well. And then it says, hey, there's a big problem. You have to scale the consumers because there's a big backlog. And that's why it screws up. Because as an engineer, you might be like, well, that's normal. This alert happens every day at the exact same time because the analytics team runs a cron job. So I always ignore it. But now you have an agent going, it's a huge problem. Now you lose trust, right? So it did almost everything correctly, but it screws up in like the last point, and now you're starting to lose trust. I don't know if you guys are using agents. I'm sure you are. You probably felt this loss of trust in some form or the other, right? And so I guess like my big push to you is, especially as a startup, and then even if you're in a big company and you're building agents, the thing that you have to always think about, and it's really, really true with AI, is if something's getting too easy, that's a problem. Figure out like what the hard problem is and start focusing your attention there, right? So we've been building this for about, I'd say like 2.5 years. And if you just walk through this list, right? The models were pretty shitty at the beginning. They've gotten pretty good now. If you wanted to build an integration to something, it used to probably take a couple of weeks. Now you can do it pretty quickly. There's MCP, there's all kinds of integrations. That's gotten easy. If you want to build an agent, it's kind of a pip install away. You can get agent SDK, PyHarness, whatever it is that you want. It's gotten pretty easy. Evals, easy. Effectively, you can get a working demo of an agent of whatever you want in a weekend. Like generally, like it might not be the best, but you can get it working, right? So the agent layer has gotten really cheap, right? And so then the question that we always ask ourselves is, well, if that's gotten cheap, what's the hard problem? Like, what should you spend most of your time on solving, right? And so to me, at least like I want to convince you guys, is that it's domain learning. So whatever it is that you're working on, whether it's code, SRE, customer service, legal, doesn't really matter. How well can your agent learn the domain? And that is what I think will set your agent apart. So I'll talk you through what we did to get really, which I hope like we got really good at domain learning with SRE. And then we can talk through like some of those patterns, right? So the first thing is I always think about, like there's a really nice Sam Altman quote, which is either we're going to destroy you or we're going to make you really good. So try to pick like the latter, right? And so if you're competing with the foundation model labs on the thing that they're focused on like day in and day out, that is a battle you're going to lose, right? So if your differentiation with domain learning is public knowledge, it's not going to last. You're going to spend a lot of time learning that, and Anthropic and OpenAI are definitely going to learn that. It's going to be baked into the new model weights. So public knowledge you should think about as a flow. I'm not saying don't do it. It might be that some form of public knowledge for your use case actually is important, but don't be too proud of it. Like, it's gonna go away very soon, right? So I think about it as focus on like what is private knowledge. And so to me, the private knowledge is stuff that lives in teams, right? Like, it's that knowledge that you have. I was just talking to somebody when we were having pizza. I was like, how long have you been in your company? And he said 2 years. So it's like, at the first day, you were probably making mistakes you're not making today, right? So the delta between those mistakes, that's private knowledge. That's like what you've got in your head. So an example of that, like what I said, is that, hey, the data analytics team runs a cron job every day. So in that case, what's a good model to think about how to get your agent to learn? And the way I like to think about it is, well, what does a new, a new human employee do when they join a company? So for me, I'm really interested in engineers, but I think you can extend this to anyone who's joining a company, right? So I think you basically do 3 things. The first thing when you join a company is you're going to try to do some mapping or some homework by yourself. That's safe, right? So if you're an engineer, I'll get my laptop, I'll get some docs, I'll get some system access. I'm going to explore. I already know a lot of stuff about engineering, but I don't know about engineering in that company. So I'm just going to explore and build my worldview of what seems to be important. The second thing you're going to do is you're going to look around for experts. Like, in that company, who seems to know what they're talking about on different domains? You might book one-on-ones. And basically what you're doing is you're going to ask them questions, and they're going to ask you questions, and hopefully you're going to learn with that exchange, right? These 2, I think, are kind of like the starting point, right? Like, you're building your initial knowledge. But the most important thing is number 3. That's like you learning from your work. Every time you're doing some work, you're going to screw up some things. You're going to learn from that. And then you're just going to keep getting better. So for us, that looks like reusing prior investigation. So what we've been thinking about a lot is how do you actually have the agent do each of these 3 things? So it's kind of a lightning talk. I can't go very deep into these 3. So what I'm hoping to do is to do this very quickly, and then we can do more questions because I think that'll be more fun. But I'll give you an example of each of these 3 and how do you get the agent to be really good at it. So I don't know if you guys can see this, but I'll just summarize quickly. The point of having an agent doing the initial map is so you're avoiding waste when it's doing a task, right? So for example, imagine that the problem is in this service, the event processor, right? So if the agent has no idea what the event processor is, imagine what an SRE agent like us has to do. Now, if I have an alert on the event processor, I have to go in and search every single system. Where is this event processor? Now that's like hundreds of tool calls, lots of context, right? Then I find it, and now I've got to figure out, okay, what are the dependencies of this event processor? Now that's another bunch of tool calls, right? So imagine if you did that mapping already, now I can say, well, these are the full set of tools I could have called, but now I can just focus on this subset, right? But this is not the only, this is an important advantage in terms of speed, but for an agent, what's more valuable is accuracy. If you guys have been working on agents, as I'm sure you have, you know that agents get distracted very quickly. They love red herrings. They start chasing after everything that looks suspicious. So imagine that even if you didn't save on the speed, if you gave it access to all of this stuff to query, it's pretty clear it's going to probably find a different path and end up somewhere you don't want it to end up. So that initial sort of mapping, I'd say, is a very important piece of any agent that you're building today. So secondly, we talked about how agents should, or at least as a human, you're talking to people and they're talking to you. This is a really big thing that you want to do with your agent. So in this case, again, this is a kind of a simple example. And so, say Cleric says, hey, consumer lag is climbing. I suggest we scale the consumers. And then an engineer says, hey, don't scale. That's the daily analytics backfill. Don't worry about it. Then Cleric should remember that, right? Because you're talking with the engineer, and the engineer is saying, hey, that's something which you should not do. The funny thing is, AI has gotten pretty good to the point that now humans giving us feedback are sometimes wrong. And that gets a little bit complicated. So sometimes like we have an instance where we'll do a recommendation and we'll get a review that like a 1 out of 5 review. And then after 15 minutes, we have a response saying, sorry, you were right, 5 out of 5. And then, but then you don't know, right? Because that's actually, it feels nice for me to say that, but it's actually scary as an engineer. Because what happens when you got a 1 out of 5, but they didn't bother to correct? Now you might learn that you did something wrong when actually you were right. So the main thing you gotta focus on is like scoping that rule to a very specific subset and not trusting it completely, right? Like if you take every single fact your users tell you as just like you have to do this, you're going to end up in trouble. Now this depends on your use case, things like that, but it's just like a known gotcha that you got to look out for. Okay, so then let's look at past work, which I think is probably the most important piece. I have a similar advice here as well. If, as an agent, you do some work like last week, so imagine it's an alert, right? You, again, don't want to take the work you did previously as like the 100% truth the next time you do it. Always treat it as a hypothesis that you have to go verify and test. So, for example, let's say the fact that you've learned is that last week, when I looked at this alert, the analytics team ran a cron job at 5 p.m. You should not take that as fact. The agent should actually go and check, did the analytics team run it again at this time, and is that why this problem happened? If yes, now you've saved a lot of time and you've figured it out. But if it verifies that it did not happen, it's just a hypothesis. It's fine. The agent moves on, right? So really, like, if you just step back a little bit, you're really trying to give the agent much better decision-making capabilities versus trying to force what it's supposed to do, if that makes sense, if you take anything away from what we're talking about. So the last thing I'd say is that it really depends on your use case, but find one metric at least to give you a definition of success. So if that number is not going up, then you're probably not doing learning correctly. So in this case, like for us, can we have, if a run with no memory, if I took 8 minutes to do that, with memory, did I take 90 seconds? If I take 16 minutes, then I probably learned a whole bunch of garbage, right? And so now I got to watch out like for what I'm learning. So that's it. If you were very bored by this talk and thought it was very level 1, we're hiring. Please come talk to me. But we're also open to being hired. It's an AI SRE, and we'd love to be on call for you. But thanks very much, and open to questions.
Who's got questions? If you do, let's stand up if you don't mind.
So I saw point, couple of questions. Point A, you said
Sure.
Hello, thank you for your talk. I'm just curious about, let's say I teach Cleric about to learn a certain thing, and for 3 months I'm always applying that certain principle, but in 8 months things change, how we engineer things. How can I, in a way, go back and fix and make sure it's not repeating that mistake? And also, I might be forgetting that that principle existed.
Yeah, great question.
Yeah.
I mean, the design question, the design philosophy of what we're talking about is that you shouldn't have to do that. Because as long as it's working, it's verifying that it's correct. But the moment you've changed the architecture, it should come up in the mapping. If it didn't, it should come up in the verification that, hey, the thing I said you should do is no longer working. So what are the memories I took to inform that? So now I'm reducing my confidence on that piece. Because if you think about this, it's not a new problem, right? Like, we've been pushing people to do runbooks, docs, and stuff like that. It's outdated as soon as you write it. It's for the exact same problem. But I think with agents, it's kind of an exciting time where agents can actually maintain this stuff for you and be that documentation for you, right?
That's cool.
Cool. Well, thanks very much.
Yeah. Thank you so much.
How's everybody doing? Good. I've got Kevin here. He's our VP of Engineering and Head of AI. And I'm Ronnie Kwesi Coleman, co-founder and CEO of Punt AI. And I'm here to talk to you a little bit about what we built, which is LLM agents that review visual assets. So show of hands, who has reviewed code before? Okay. And who here knows or has ever reviewed marketing assets? Few people. All right. So there's a whole industry, a lot of people that do manual review of marketing assets. And that's what we'll talk to you about today. All right. We work with these really large companies like Nestle, Danone. They make a lot of marketing materials. They make a lot of packaging. And if you think about how many assets, so think about like an ad you see on Meta, or you see a drink that you have. There was some sparkling waters. Everything there has a package on it, an asset that you review, right? So it's a visual asset that humans, teams and teams of people are reviewing for brand consistency, quality control. They're reviewing for regulatory issues so that they don't get embarrassed. And there's thousands and thousands of them. It takes weeks and weeks and weeks and costs companies a lot of money, right? And so we learned about this problem about 2 years ago through the marketplace that we had built before this. And we decided to go fix it. The thing that we had to do, it sounded simple, and we'll get into, but what we had to do was take brand rules, regulatory rules, and review them against marketing materials. Who thinks that they know how to solve that problem? Don't be shy. Because we give this test to a lot of people, and everybody's like, this is easy. I can do it. Nobody's confident that they could solve this? This guy, I like him. All right. A lot of people thought it's simple, right? So the failure that we had a lot was that LLMs out of the box are bad at visual assets. So I'll let Kevin unpack this problem a little bit.
Awesome. Thanks, Ronnie. As Ronnie was saying, we give a simplified version of this problem for some of our AI engineering interviews, where we have something like a set of guidelines and then a set of like 10 to 20 assets that we need to find all of the problems in. Like many people, when we started working on this problem, we first took a naive kind of baseline approach, which is one of the problems, which is one of the approaches that many candidates that we see take as well. What you find very quickly, if you're just doing this in a kind of like standard foundation model, is that there's a lot of problems, even with visual language models, for actually being able to provide the precise spatial and graphical interpretation that we need for the type of marketing assets that we're providing feedback on. A lot of things that really matter are things like the precise color that is used, the exact layout, precise measurements, and all of those are pretty hard for an LLM to get out of the box correct to the degree of certainty that we need. So what we often see here is that candidates are leaving too much up to the LLM and producing inconsistent or unreliable results. Yeah, and this is all on the interpretation side of how can we make sense of these packages. And then the other problem we have is that when a actual human is providing feedback on a package, they're not just providing a list of information at the end of it of here are like the 3 problems that you need, but especially on images, it's helpful to know exactly where that problem is. So while the first problem we faced was on getting the LLM to understand the assets that we were reviewing, the second problem is then on providing feedback back to the designer in that visual format that they're very used to. So one of the problems here was that we need to place exact pins on the asset that we're reviewing that indicates this is exactly where the shade of the color you're looking for is off. This is exactly where the logo is in the wrong spot or is an icon that is not approved. And so this was the second problem that we have, where we need to take the information we have about an asset and use that to provide the actual output. We worked on this problem with a lot of different approaches to this, and then on the next slide we'll see what we ended up with as an initial solution here. So one of, as I mentioned, we started with the naive approach, which was just a large language model. But one of the things that we saw was that that building scaffolding around large language models for some of the cases where they're not very good was a way that we were able to dramatically improve the accuracy of the feedback that we're providing here. On the left side of the screen, you'll see some of these kind of more traditional, like pre-ChatGPT, computer vision, and machine learning techniques that we're able to use here. And these are all around taking some of the work that visual language models aren't as precise about, and then giving them tools, giving them additional ways to ask questions about the image, and to use more deterministic tools. So you'll see some of these are optical character recognition for just extracting text, especially if there are handwritten or different orientations, different languages that we deal with. Being able to extract that directly as opposed to leaving it up to a large language model was definitely one of the ways that we were able to more accurately identify things like copy errors. Layout analysis, very focused on structure and format. You can think about like tables or charts or different paragraphs that you might have, as well as some of the different images and icons that I mentioned we might deal with. And then finally, also being able to use more traditional computer vision tools, such as clustering, different color analyses, and different ways that we're able to look up the precise coordinates of a particular phrase. If there's a typo in a 10-paragraph page on a large ebook, just kind of having a general pin isn't good enough to know exactly where that problem is, but you need to be precisely on the word that is having the problem. And so we first do these more deterministic approaches, and then there are also cases where these more deterministic approaches might disagree or might have conflicting information. So we are able to first use these as inputs into an initial step where we really are developing our highest confidence representation of the asset that we're reviewing. And this could be an image, it could be a text document, it could be a video that we're trying to provide feedback on. But the goal in this first left side of the screen here is to create the highest confidence interpretation we can of the asset that we're reviewing. Once we are able to do that through all of this pre-processing and tool use and reconciling this with a large language model, only then is the point when we pass it on to our review agent that is in charge of actually doing the work here of taking that high confidence image interpretation and then identifying all the guidelines that are relevant to it, and then identifying the exact violations that might be on an image. So what we get out as a final output here for the pinned output is not only the coordinate, or not only the exact problems or infractions and the solution that a designer should take to fix it based on their guidelines. Maybe you need to change it to a different color or move to a different layout, or add a different claim or disclaimer to the asset that you're doing. But we also get XY coordinates and a timestamp if we're doing a video. That is all very important for us to be able to provide that feedback in a visual way to the designer. And so, yeah, one of the main learnings from this is that while LLMs are great at a lot of things and are very good at handling the ambiguity, that as often as possible, and I think a lot of people are trying to hand off some of the more procedural, deterministic work that an LLM can do, and hand it off to some of these tools, even more traditional machine learning techniques. And that is one of the ways that we've been able to provide very precise feedback on some of the assets that we're reviewing here.
We're going to get some questions going. Who has questions for Kevin, Ronnie, anybody? Let's go. I'm going to come back to you. I'm going to start back here this time.
Yeah, thanks, guys. I'm sure you guys have gone through all the frontier models and you're probably using them in your daily workflows. I've used like 4.7, ChatGPT 5.5, a bit of 3.1 Pro for some visual feedback to say, hey, you've designed this. What is wrong with this? Design a V2, V3, get the kerning right, the formatting right, the layout right, and here's a reference. So it's able to get there, I would say, about 60% of the time, at least the frontier levels. But but you're trying to go one step further, I'm assuming, right? You're trying to be
Yeah.
pixel
Yep.
perfect?
Yeah, for us, we need accuracy to be at 95%. Because these are large enterprises where regulatory and compliance work is highly critical. So it's not just, did I get the wrong color blue, but also did I say the wrong thing on this packaging? And if I send it out to the printers, it might cost me $10 million in a recall. So the accuracy has to be super high.
Awesome, awesome.
So a question from engineering perspective. So how I understand this is you have, let's say, one image, you break it down into different layers. In one layer, you figure out what the text is. In another, you figure out what the color scheme is across, and then eventually you put it all together in a LLM. But how do you do the stacking again? Because these three, I think I saw in that slice there were like three different boxes which do different stuff, but they produce output in different format. Now how do you put them back together into a reconciler?
Yeah, we reconcile a lot of the feedback that we have there. And that's part of what part of what the reconciling LLM is doing, is helping us identify like what text from the OCR model is in this particular chart, and it's really all about being able to combine those specific tools. So in some cases, we're able to determine which ones are going to be related based on things like overlapping bounding boxes that might be there. And then there's other cases where it's less deterministic, where we might be using some of those initial tools as well as a visual language model. And so there's cases where we'll have this extra kind of metadata information along with a visual language model that is able to reconcile all of those differences.
Hey everyone, I'm Feifan, co-founder and CEO of Tanagram. My talk is about software factories. You might have heard this term. There's a lot of kind of different definitions for what it means. But I wanted to kind of talk through some of the primitives that we've been seeing and some of the cool things that we're seeing on the frontier of software development. So like I said, I'm the co-founder and CEO of a company called Tanagram. I'll talk about that in a moment. Before that, I was an engineer at Stripe for many years. I helped build the issuing product, and Stripe is a large engineering team with a lot of complexity, and so a lot of what we're building now was shaped by those experiences. And before that, I was an engineer and generalist at a bunch of other startups. Before going forwards, this is just a brief peek at what we're building. It is called Lore. It is a place to collect all of your agent transcripts from Claude Code, Codex, and Cowork. I will leave it at that for now, and you'll see why it's useful as we go through the talk. So I think where we're seeing the software development go is kind of this transition from no AI to tab completion to coding agents. And I think now a lot of teams are sort of facing this transition, right? You can sort of give into the vibes. You can install Gastown and Beads and GStack and run your 10 Claude codes and see whatever happens. Or you can choose to buckle down and industrialize your software production. You can choose to get serious about putting these guardrails and frameworks in place. And I think this is what this talk is about. So I want to give sort of a sample platter of a couple of the building blocks that we've seen to be useful as we've been building our own software factory. This helps us ship 40 PRs a day at our team while maintaining high quality with a team of 5 engineers. And so this will, like I said, be a sort of a sample platter. Feel free to ask me questions, and we'll go into details afterwards. So the first piece is very boring, right? It's your good old foundations, your linters, your type checks, your tests. And what's really important here is that you want to make sure that they're really, really reliable and really, really fast, because your agents are going to be running them hundreds of times a day. So from our own code base, we set up a little bit of a harness so that we can run all 3 checks locally in parallel, and they all finish within 15 seconds. We're tracking these metrics in post-hoc so we can be alerted on our team if these metrics breach, so we can keep this standard high on our team. And so I'll do things like go ask my Claude to run this command make sure not to use any caches. And I'm saying, type checking is taking 13 seconds. That's too long. And so I'm asking my Claude to go fix it, right? I'm asking my Claude to catch regressions, to suggest improvements for how we can make these things faster. And in this particular case, Claude goes through, it runs through, and it comes up with a couple of suggestions for what might be useful. And so I ask it to test all these proposals, commit the ones that don't break anything, and results in meaningful speed up. And so earlier this week, we actually shipped this improvement into our own code base, where the lints used to take 10 seconds, got down to 5 seconds. The type check used to take 13, got down to 9.6. And then our test wait went from 15 to 13.8, right? And so these are a couple seconds of savings, but they compound over the hundreds of times that we're running our agents across our team in CI. And so you have to just drill on these foundations and make sure they're really, really solid. The second part is this idea of self-verification. And so this is kind of like a really fun, creative exercise, right? It's like, how can you push your agents to verify their own work all the way through end to end, right? And so, like I said, we're working on this tool called Lore, which is a way to upload your agent sessions. And last week, we had this bug where it doesn't appear to be uploading my Claude Code sessions. And so I'm thinking about, how can I run our whole stack in an agent, and how can I get it to actually run Claude? So I'm asking this agent to run Claude in a TMUX session, actually go type things into Claude, watch some logs on my computer, and then curl our dev API and use that as a verification loop to make sure that this flow is working end to end, right? So it's this idea of how can you assemble all these pieces, and how can you tell an agent to run all of these pieces so that the agent can actually make sure things work end to end. And so this practice of figuring out self-verification is really important. Here's another example. We have a CLI. It's basically an NPM package that lives on your laptop. And we built an auto update functionality. So as you're running different commands, it's automatically downloading the latest version and installing it. So we don't have users on older versions. This broke at one point, so we had to go and debug it. And so the way I had my agent debug it was to literally just commit and push changes and merge to main, let our CI deploy a new version to NPM, and have it run our CLI locally and make sure that's picking up the new version. And I told my agent to just automatically merge PRs onto our main branch until this is fixed, right? So you kind of think outside the box. You're not just limiting your agents to writing code. You can have them push changes. You can have them check NPM. You can have them run terminal commands and run things in TMUX sessions to really make sure things are working. And that's how you can really leverage agents' ability to do things and fix things. The third piece is evals. And I'm sure many of you have, if you've built agents, you've seen all sorts of different eval platforms. The really important part, though, is this ability to not only go through and annotate your data, but to have some kind of eval tool that allows you to actually iterate on your code using your labeled data and self-improve until your results get better, right? You can call this hill climbing. You can call, there's a sort of a spec called auto research. But the idea is that you want an eval tool that has a built-in self-improving mechanism. And so the one that we happen to use is Bitfab. This is not meant to be a plug, although the Bitfab team are friends. But the overall point that I'm trying to make is that it's only evals if you have replay and self-improvement. Otherwise, you just have a fancy spreadsheet. The fourth piece is this idea of cloud skills. And so this is something that we've set up in our own Slack. It's a digest of the PRs that people have merged every day. And so that's like a pretty basic automation, nothing too fancy there. But the cool thing here is that I didn't have to write any code for this, right? All I did was basically write 5 sentences in a prompt. And there's sort of this growing contingent of tools that allow you to deploy these plain English prompts as a whole service, and they can run them in the clouds. So OpenClaw is an obvious one. Everyone's probably heard of that. There's a couple of other tools that I like as well. Zo.computer is like a computer in the cloud. So you have storage, you have sort of a persistent server. You can text it, you can send it emails to trigger these jobs. It can also run crawl jobs as well. And then Valet is another tool that allows you to just write a skill or write a couple sentences, deploy it to the cloud, and run it. And so we have a couple of these little automations that are basically just skills in the cloud. And then the last piece, the last building block, is this idea of threads. I did mention that this is a product that we're working on, so this is a little bit of a plug, but it is useful in the sense of, we're capturing all of these threads, and so we're adding them to all of our PRs as additional context, right? These threads capture information about why features were implemented a certain way, the decisions that engineers tried and abandoned, the directions that they gave or didn't give, and let the agent figure out. And so we're including this as context in all of our PRs now, and it's been useful for debugging why something was built a certain way. We're also finding a use case where this is a way for our team to collaborate, right? As different people work on sort of different features, or they're researching different aspects of something that we're trying to do, we can fork their threads and continue the conversation. So for example, we're discussing an open source strategy. And so someone on my team yesterday was researching the different open source options. Later that night, I took their threads and I continued the conversation. And I was like, what is the difference between option 1 and option 2 in their thread and this third option that I also had in mind? So you can sort of collaborate on the work that people are doing between these different threads. And so that's been a useful primitive for our team as well. So, like I said, that's a quick wrap up, or that's a quick sample of a couple of the building blocks that we've seen be useful for our team. My name is Feifan. We're building lore. I'm happy to answer any questions.
All right, that was great. Who's got questions? Anybody with this is good. Who's got questions? Anybody want to talk about it?
Write any code, so I was wondering how you solve that problem.
Yeah, I think, so this ties into the foundations piece, right? Anything that you want to do repeatedly, you should try to figure out how to write that as a deterministic test, and you should try to make that test fast, right? So you can run that on every iteration. I think the self-verification piece is part of its foundations, but I think what's more interesting is like on a case-by-case basis, right? In this one case, I am trying to fix a bug in our auto-update mechanism. And the point I'm trying to make is that instead of trying to mock that functionality and sort of use a test that way, which isn't really testing what you're trying to do, right? I can just have my agent actually make a PR, check NPM, and make sure that the version on my computer is now the latest version, right? So it's just thinking about like, what else can I tell my agent on a case-by-case basis to actually verify that the problem is fixed instead of trying to do mocking and solving individual pieces of the problem.